final hour or final 90 minutes. We want to talk about publication of software. So this is a bit sort of what we have seen today, that based on the open access movement, which started some years ago, we also have this open data movement, what is sort of extension of open access principles used for data. And we also have a relatively new wording, which is mainly open science. And open science is something that we feel where also software belongs. Since when we look at the scientific world, then it started with open access, making open your paper so that everyone can read it. And okay, we start to open the data as well. We can even publish data somewhere on a platform, on different platforms where we get DOIs, digital object identifiers, like we know it from papers, for data. And we also have, since a short time, we have the opportunity to get also for software DOIs, digital object identifiers, so that we can be part of your publication list, for example, which is currently on the way, and is something that somehow belongs to open science. The other word is the free and open source software movement, which is well present over tens of years, and has a slight different focus, but nevertheless, what we are mainly doing in the scientific world is that we, of course, try to reuse the principles from the free and open source software movement, try to reuse principles from software engineering. And we will have a short look at what is possible nowadays when we want to publish software, and what might be possible in the future. So there are a huge amount of challenges we have to face, and some of them are already somehow addressed. For example, when we talk about identifiers, the digital object identifiers, it's already possible to assign a digital object identifier to a software release package, upload it to Zenodo. We will show that later. Also, it's possible to archive software, so that's available maybe in 5 or 10 years, so that others can reproduce your paper, for example. And there are a lot of other things which are not really covered when it comes to software. Lots of people try to find ways how to cover the challenge of quality, so that the released software packages are reviewed as well, so that we can have sort of quality stamp, that we can say that the software can be downloaded and used with specific data to reproduce a paper, for example. There are also some metrics, and the metrics come with the identifiers, for example. So when we start referring in papers to software releases and not to papers who describe the software, this is a certain metric which allows us to identify which software is important to the scientific world, because with these metrics you can identify those papers or many papers who use the same software. Another challenge is the documentation and also the impact. Documentation is also part of the quality thing. That means documentation can be done on different levels. We will see what kind of levels this could be. And impact as well is something that, especially for us, for example, we work at the section which is, or a sub-center of GFZ, which is called Center for Geoinformation Technology. So we are more on the technology part, and our output in writing papers is relatively low compared to what other sections are doing. And what we would like to see is, for example, a staff page with our publications, where we not only have listed our conference contributions and easy published papers or easy cited papers and reference papers, and that we also find here maybe some research data that is published with the DOI, and also software that has been published, so that it's part of our scientific or research output, and it has also for us as researchers a specific impact that allows others to acknowledge our work in a specific way. So what is state of the art? When we want to publish software, then there are software journals. Each of these journals use individual policies for software-related papers. Mainly that means you write something about your software. And based on the policies and how strong these policies are, it means that you have to provide the source code on a public repository, or you have to provide it as a complementary material which is published on the website where the paper is available. So there are different journals, and they all have their own individual policies, and you mainly write something about your software, but the source code itself or the software release itself is handled in completely different ways. Then we have also digital repositories, which are minting DOIs for software code copies and software release packages. We will show you an example after the presentation what is possible so far. We have, of course, foundations and companies providing the environment for free and open source software projects. When we think about companies, we have, for example, GitHub. GitHub is a company, and they have a Git-based repository, and above the Git, they also have, let's say, a web page which allows you to interact with this repository, with the user interface, and they also put a lot of social media functionality on top of this Git-based repository. This is a company which provides services which are used in science already. We also have foundations which maybe provide a specific harbor for communities, and they also host projects. In the geosciences, for example, this is OSGeo. We also have the Eclipse Foundation, and there are also other foundations, non-profits, who provide a harbor where you can put your open source projects. And it's the same here. They also have their own individual policies, and you have to follow these policies if you want to be one ship in their harbor. However, they provide services which are very, very useful for you when you maintain a project, which is also interesting for the community. And finally, we have institutes who are offering software code repositories and digital repositories for research results. For example, when we look at the library here at the Science Park, which is offering services for the different institutes here at the Telegraph Hill, then, for example, you can start publishing your data there. Of course, you can publish gigabytes. You can, under specific circumstances, you can publish hundreds of gigabytes of data. But if you have a small package, which was explained with this long tail of research data, then you can publish a relatively small zip file there. You get a DOI, and you have a landing page where you have given your description to this piece of data, and so your data is available with the DOI just via the services from this library. And this is something that is also extended this service. That means in a few days or weeks it will be possible, like you are doing it with data, that you can publish your software. You just bundle your software in a package. You go to the library and say, I have a piece of software here, and please publish it. I want to have a DOI so that I can use the DOI in my paper and refer to my software I've used in the paper. However, in that case, for example, there's also a specific policy which basically means you provide a zip file and some further information like a description or something like that, and in the end there's no sort of review process or any hint that this piece of software is of good quality. And important to say, when you just zip your software, then of course it's decoupled from the ecosystem where software really lives, like in a repository of GitHub, where you have the social interaction with other developers, for example. Okay, what does it mean? When we look at these software journals, then mainly you have these software descriptor or paper, you write something about your software. which is one way you can, this is something that you can also do for several years right now, and you still have the question, in which journals should I publish a paper which describes my software? Mainly this is, and this is interesting, until there's a radical change in the way that academic credit is given, the principal record of scientific research is still the peer-reviewed publication. So this is the state of the art. If you really want to have, if you want to get acknowledged for what you are doing, it means right now you still have to write a paper in a journal that is listed in EASY, Scopus or whatever, and then you will be acknowledged for that piece of software. So given that software is a fundamental part of doing science in the digital age, the questions we are often asked is, where can I publish papers which are primarily focused on my scientific software? And the SSI, which is an acronym for the Software Sustainability Institute, which is a sort of project which is conducted in the UK for several years right now, and they are very successful. They provide an updated list of journals which accept submissions that are primarily about the software. And you can go to this webpage there, and you will have a long list of those journals which might be of interest, and you will find, before you start looking up it for yourself in the net and search world, you will find in a relatively short time 2 or 3 different journals which might be relevant for your field, so that you can write something about your software. So this is the state of the art. So what are you going to do when you write this paper? Of course, you will refer or link to the source code. This is the standard way to do it right now. What happens over the last 1 or 2 years in research is that you just, that lots of those who have written software just point to the repository in GitHub. So github.com/blah blah blah, this is my repository, there you will find the code. But here, first, let's say mistakes are made, because your paper, I mean, it is, you describe your software, or you either describe your findings and you refer to the code, then lots of these people are just referring to the repository, but not to a specific state of the repository. So you can tag a specific state of your repository, which means that you make a specific snapshot, which also stays in the repository. It's just, it gets a specific label. You can, for example, label it version 1.0 or something like that, or you can just label it, this is my version used for the paper with this DOI. And you should really make a difference here. So when you write something in the paper, make sure that you have a specific version somehow labeled in your repository, and that you refer to this version, so that people who are reading your paper 3 or 5 years later still find a version that was meant or is directly linked to this paper, and is not a newer version which is which has been updated over the last 3 years, and possibly is not providing the same functionality as it was 3 years ago when you published a paper. This source code mainly lives in the software code repository, as already explained. You also can refer and link to research data. So when you write something about your software, you of course working with data. Most likely you use data and do something with the data in the software. And this is the research data, and the research data itself can have a data descriptor or a data paper as well. So for example, in Earth Sciences we have, by the Copernicus publication, we have a journal which is named ESSD, which is Earth System Science Data, and this is a very good example, and they are very successful. It's a very, very good example that this clearly is a data descriptor. That means the data is published somewhere else on a platform with a DOI, and then you write something about your data. It's a data descriptor following a specific structure in this paper, and the reviewers then follow the structure, given criteria, and they check, for example, if the data is available, that it's under a specific license, that the metadata is available, that the metadata explains properly what sort of data it is and how to use it, and so on and so on and so on. And they even cross-check on the platform where the data is offered to other researchers, cross-check if, for example, the download button is somewhere on the web page, on a prominent page, because there are also platforms which just have small links you most likely won't see or something like that. So it's really the journal that is also asking the platform providers to say, we only will publish this paper about the data which is hosted by you when there is a download link which everyone sees on the first site on your web page. So the data descriptor refers links back to the research data. You may have also test data. This might be an interesting thing when your research data is gigabytes or terabytes, and a small set of it can serve a good test data that others can use with your software without downloading the whole bunch of data. And the software descriptor paper as well is accompanied by metadata saying something about the software itself, and normally in the journal then it undergoes a review. It's stored in a digital repository and it gets a DOI. So this is possible right now. Furthermore, you can use this source code, you can bundle it when you put it in a digital repository and you get a DOI for it. And you get also a digital, you get a DOI when you put your research data in a digital repository, and you can even do this for the test data. This is, and also you can write something about the data. So this is a data paper at least describing your data, and you can put this in a digital repository as well. So what this image should show is that when you work on a specific aspect in your research, and normally you just publish one paper describing your findings, that's it. And you mention your data maybe, and you mention your software somehow. But in reality, it's already possible that you gain 2, 3, 4 DOIs just for your research when you cover all the stuff that is involved in your research. That means you present your findings in a paper, you upload your software, your code somewhere, your software release somewhere, where you get a DOI, you can write a paper about the software, you get a DOI, you publish your data which belongs to your findings and get a DOI, and you can write a paper about the data and you get a DOI. So with the same findings and a bit more effort, you get 5 DOIs, which basically means you have lots of research output just by the thing where you right now just publish one paper. So your work is much more acknowledged, and what's also important is it's much more reproducible because it's stored somewhere, it has a DOI, it's preserved, and others can follow what you are doing and can download all the stuff and reproduce the stuff you have described in your paper. Another way, and this could be the future of how software is published, is that you bundle a software release for publication. And this is something different than just talking about source code, because in a software release, it's a real package where you put things in which is a bit more than source code. So you put in your source code in this release. You may also add some test data so that using the source code and the test data, you can start immediately doing things with your software. If the research data is not too big, then you can also put it into the software release, or you at least provide some information in this release that it refers to the repository where the data lives. And you can also put some information about the software, or you should. And these are completely different sort of information you can provide. For example, the first thing you would provide is a user guide, so that everyone who's taking this release and extract it knows how to use your piece of software. So just for the users. And if they think, hey, it's a nice piece of software, I would like to use it maybe on a cluster, or I would like to use it on a server because it's much faster or something like that. You need sort of installation guide, which you either use on your own so that you install the software somewhere else, or you give it just to your administrator and say, I need this for a specific time, so please install it somewhere where it's available for me and where it's with much more resources than just with my small laptop, for example. Or other users can use this piece of software as well on a server. And after that, it might be that they who are using this software find this software so useful that they say they want to extend it. But they need information how to extend it, and so they need a sort of developer guide. That means they have to know what has been your setup when you were developing. Did you use a specific IDE? Did you set it up in a specific way? How did you plug in your data? How can the data be changed? Are there certain locations in the source code where you finally can make some extensions, for example? So whenever you are writing software, you can also start to make taking some notes, either inline in the code, or you are taking it separately in a sort of guide where you give some hint. It must not be very extensive. You have also seen it in the data management plan. It's more that sort of giving enough information, which is not too extensive, so that others can do something with it. And this from time to time is just one line, some hint, so that others know, okay, here I can change this, or here there's something with the performance not good enough, so maybe I can do something here. So provide as much hints as possible. And regarding the data, you may also complement some information about the application programming interface documentation, which basically means that others have information about how the data can be accessed over a standardized interface. In the best case, it would also be complemented by the binaries if possible, so that, that those who are using or downloading the software release for publication not only have the source code because there are different sorts of languages. There are compiler languages and there are also interpreter languages. What we have seen yesterday is Python, and Python is interpreter language. That means when you start it with Python, there's a Python interpreter and reading the code when it's executed, and then it's doing that stuff. But there are also compiler languages like C, for example, or C++ or Java, which need to be compiled before something is run. So providing the source code here only could create a barrier for those who don't like to compile this piece of software. So it also depends on the language you use. So when it's relatively easy to provide also 1, 2, 3 binaries for different platforms, and they are relatively small, then you should put them in this package as well. And you can, of course, provide some metadata about your software. And they finally are managed in a software or code repository. We have seen it yesterday. You can mainly use Git, for example, for text files or code files or documentation files in a text format. But of course, you can use this also for small binary things or images or something like that, which doesn't change over time very often. What's missing so far, and that's a very challenging thing, where we are back to the challenges from the beginning, is how do we review such software release? Because there are different sorts of reviews here, because you have those who are, from the scientific point of view, are the experts in a specific field, and they should evaluate the software if it's really doing what it's intended to do in a specific scientific field. And you also can review it by, let's say, people working in informatics, developers or something like that, who look a bit differently on your software package. And this is something which is just in a transfer phase, where people think about what should really belong to a release in science and to a software release, and how are we able to establish review processes so that we finally can put on some quality badge on this release. Okay, after the review process is done, it's going to the software code repository again, which could be a Git repository. We already learned the difference between Git and GitHub. And finally, what is possible right now is, so you can still do as well. So this is the second approach. You can build your own software release packages. Tag them in your software code repository. You can even ask your peers to review them so that they show, okay, I'm able to work with a piece of software with the information given. So everything is in, I need or other need to use your software. And then a bit of something happens, which is, it is a solution right now. And the question is if this should be the solution for the future. that you take a specific copy, take it out, put it on a digital object repository like Zenodo, for example, and then they provide a landing page. It's connected to the DOI system, and you get a DOI for this specific software release package. Possibly it's a good idea to stop here shortly to show you some videos so that you get a better understanding of what I'm talking about. This is one. Okay, so this is Zenodo, and what happens here is that already someone logged in here is going to the profile page, is going to a pane saying GitHub, and then there are preferences, and one preference says because this just pause it here, because what you do here is that you can connect Zenodo with your GitHub account. That means you can even use your GitHub credentials to log into Zenodo. And both have, Zenodo and GitHub have a cooperation so that they can communicate with each other. And what you can see here, that the specific developer has a repository in GitHub which is named Snippets. And the first thing he's doing is he flips a switch to on so that this repository is connected to Zenodo. And the next thing is that he creates the release. This is the second step. So he goes to GitHub, opens the profile, opens the repository named Snippets in that case, there are no releases yet, and we want to create a new release. Nice user interface again, so there's nothing to type on the command line here. This is why we love GitHub, because you get a nice web user interface. And he's creating the release with a web interface version for showing something. You can provide a description, and in the end, he's able to publish the release with this button. Okay, so this is a version to showcase Zenodo DOI minting with a release that was done in GitHub. So what happens further is that we go back to Zenodo, and we want to get the badge now for this release, and that means we are still on the old page, so we have to reload it. So you can see the badge is missing down there. He's just going back to GitHub, okay. Then he's going back to Zenodo and is refreshing the page. And you have seen that there's a new badge. And this is a DOI which has been minted by Zenodo based on the release created in GitHub. So this is something that is available right now. But it has also some drawbacks, because when they created the partnership, they started with a fairly limited communication, Zenodo and GitHub. So you get some metadata automatically from GitHub so that you will have a release with a DOI in Zenodo. So there is another way to publish your software release in a way that you do it directly in Zenodo with a prepared zip file. And this is the other way to do it. So you say upload, you have prepared a release, a zip file for example, or it's just a Python code, or you can upload several code files or documentation files. So it's up to you how you structure your release. And the thing here, what happened here is that when you then uploaded the file, you get this sort of form where you specify specific information. And you can see that here in Zenodo you can publish publications, posters, presentations, data sets, images, videos and audios, even lessons, but you can also upload software, a release in that case. And the next thing is this button. That means preserve DOI, pre-reserved DOI. That means you are still in the upload process and you can request a DOI before you publish it. Basically, this allows you that you can prepare this release in Zenodo with this DOI with all the relevant information you want to provide, and then you go to your paper where you describe the software or where you present your findings, and you can already start using this pre-reserved DOI in your paper, and then the paper gets published with this DOI. After your paper is published or is accepted for publication and just undergoes some processes at the publisher, then you can start finally releasing or publishing this software release in Zenodo. And you can also integrate then the DOI here, the DOI of the paper also in this release, so that both cross-link to each other, which is very, very nice. Okay, then there's a publication date, there's a title. In that case, this is a Mongo 2CSV script, so you can download data from a Mongo database and put it into a CSV file. You put in some author information, who has been the author or the contributors in that case to this piece of software. You can add the affiliation, you can add the description so that there's a bit more information. You can even add keywords to it and additional notes, so you have lots of information available here that can be provided beyond the way that you have been seeing in the previous step, where you have been doing a release directly coming from GitHub. You can even select a license, and you can see here that there are tons of licenses, which is also important because GitHub only has maybe a list of these licenses you can select, and Zenodo provides you such a list of licenses. You can provide further comments, you can say something about the funding, this solved this. You can also refer to other identifiers, you can name contributors, you can put in additional references here. For example, you can mention the paper that has been published just right now for this piece of software. You may even refer to a conference or a book or a thesis or to different subjects. So there's really a lot of things that can be configured and provided as information here. And in the end, you will have two buttons. One is the save button and one is the submit button. And the thing is, the first time you are doing that, you probably will take the save button. That means your release is prepared with a pre-reserved DOI, and then you take the DOI, put it in your paper, undergo the review process of your paper, and finally the paper is published. You know the DOI of your paper, and then you can also add the DOI of the paper here in this metadata, and then you can press the submit button. So it's more a two-step approach where you prepare everything to get a DOI, and the second step is, after the paper is published, to submit it finally. So this is the save, and this is the submit. And in that case, we want to submit it. This is still the information that when you submit it, there's no way to change anything here. So this is why there's this two-step approach. And when you have submitted it, then it's available as a published piece of software with the DOI. And just to show you that this stuff is also resolving, which one was that? Okay, when you are back at the Zenodo page, you can get the DOI from your software release. You can change to a DOI resolver like DX, DOI org. You put in the DOI, say go, and you directly hit the landing page of the software you have just released some months or years ago. And this would be also the way that others who are reading your paper where the software is referenced would do, and they could get the software directly. Okay, so this is possible right now, so you can do it. Just start doing it. What could be the future of software is that a software repository or code repository which works similar to GitHub, for example, or maybe GitHub itself, is able to provide a landing page and is connected to a DOI system as well, so that after the review, the release, the initial release, which is still in the ecosystem, gets the DOI, and you don't need this way of going to Zenodo and just storing a copy, because then in the repository, the specifically tagged version, a specific branch or whatever you're using there, gets the DOI and it still is in your repository, and those who are just resolving the DOI will hit this, let's say, will hit GitHub landing page and get all the relevant information about the ecosystem, the social interaction, about the developers which are also which also work in this release, and so on and so on. So this could be something that might change over the next 1 or 2 years. And the nice thing about that is that scientists have a workplace and they can start to fork and clone directly from this directory. And this is something, when you have a zip file, this is not possible, because the zip file, you're not downloading it, it is not really stored in a Git and so on. They can, with this version, they would be able to just create a fork or a clone and start working on it. And they can even make changes and push and pull or submit information back with the changes they have done. And it's also possible to archive these piece of software with the same mechanisms provided by a version control system like it. Okay, so what is required so that we can start doing this stuff is that we need infrastructures and platforms which are already available. You have seen it, some of that stuff can be done. So Git, GitHub, Zenodo is there. We need to prove some proven software engineering practices, which basically means you have enjoyed the last 2 days, so you are well prepared. There will be much more coming, but the first steps are done, so you know how to structure your code, how to work with databases, so you already have some engineering practices. We know established publishing processes. This is nothing new to us. We all know how to publish a paper, so it's just a tiny step to publish data and to publish software, because only the digital object changes, but the rest remains the same. What we also need are the skills. So that means we have to understand what might be a bit different between publishing a paper and maybe between publishing data or publishing software. So we have to do it to get some skills. Basically, it means everything is there and we just need to merge, test, and evaluate it. And it will happen on your workplace. So you have to do it. And when you start doing it and show that it's relevant in your work to do it that way, then over the time we will also have the policies which support this work with resources, for example. So what we have seen today is that there's a sort of data management plan which is coming slowly, and it's already there. You can still opt out from time to time. But there are policies which mainly say if you are working with data in a project and you apply for a project and want to get funding for a project, then we cover some of your work with resources, mainly with money, to handle the data. And the next step is that you get money for handling the software in your project. So a software management plan is already under preparations. For example, when we go back to the UK activities of the Software Sustainability Institute, they already provide a website where you can start creating, or which supports you by creating software management plans. So whenever you apply for a project, you can consider, for example, not only providing a data management plan, you can also provide a software management plan to show what sort of software you intend to develop or bring into the project, and what's your intention to do in this project with the software. And of course, keep it simple, gain experience, and improve successively. so that you get all the skills and you are the ones that bring in these new type or part of publication and acknowledgement of this fundamental part of science, which is software. So this is the first part of the presentation. Are there any questions? If not, then we will go to licensing. So licensing is something which is not a really nice topic, because you have to consider things which seem to be not natural and which are created more on legal issues. Problems are created on legal issues, but you still have to. You are still faced with them when you start developing your software, because you are not going to develop the software from scratch. For example, you will start using Python, and Python is available under a specific license. The next thing is, for example, that when you started using Python yesterday, you also started to copy and paste some code snippets from the internet. The question is, under which license is that? So just with some simple steps, you create problems when you want to do something with this software after you have written it. So mainly that means you have to clarify the use of libraries and the licenses. You have to check the compatibility, because it means when you use a library from this page, and a library from there, and a library from there, possibly 3 different libraries, and you will have 3 different licenses. And the question is, can you use it in your software without any conflict of these different licenses? Possibly, or in the worst case, you have to re-implement those libraries which are problematic. So if there's a license conflict, you may have to re-implement things just to do something with your software later on. Another thing is, you have to clarify the use of copy and paste. That means you have to trace your quick and dirty solutions with comments in the code. So basically it means, where did I copy from this code snippet? Everyone is doing that, because you are not writing it down and then it works. It's more or less, oh, I have a problem, how do I solve it? I look up in the internet, I get a piece of code somewhere in the internet, I take it and I paste it there. And half a year later, I see this code and I don't know where it's coming from. So just copy the URL where you have taken the snippet and put it in there. And later on, when you want to publish your software, you can run through your code and you can check these locations in the source code, go back to the URL where you have copied it from, and you can check back, okay, it's this license, I can use it, I don't have any problems, or I have to re-implement it in a specific way so that it's clear that it's not a straightforward copy. Then there is another step, which means before publishing it.
Excuse me.
Yeah.
When the URL is at that time no longer existing.
Well, then this is a problem. Yes. You may even can start. I mean, the thing is that these copy and paste things are most likely done quickly. That means you have a problem, you are going to copy and paste it, it's in your code, and the next easy thing to do is just to take the URL and paste it as a comment somewhere, and you know, okay, this belongs to there, and I can check back later. If you would really spend the time, then of course you would sort out in the beginning, when you start copying it, under what license is this stuff available on that website. So from time to time it's easy, because there are lots of websites which have these CC BY by default. That means whoever is providing the website or whoever belongs to a community of that website where code is shared agrees that everything that is shared, for example, by CC BY or under a specific license, and then it's automatically displayed under some or at the bottom of the pages, for example, or somewhere on a specific page. From time to time, it's really easy to find, maybe in a minute or something like that, but on other times it's almost impossible to find any hint under what license this code snippet can be used. So this is something normally you should check from the beginning, but practically no one's doing that. So the most practical thing is just to copy the URL, because that's quick. It's just 3 seconds and you're done with it.
What detail do you have to do that? I mean, if give a little snippet from like Stack Overflow, or I mean everything is documented everywhere, so do I have to paste the URL for every line of my code? Or?
So it depends, because I think, of course, when you start developing a software, most likely you will take a lot of copy and paste. But there are, for example, when you start developing with Python, you may also use the Python documentation, which is recommended. Not just try to use the documentation, the official documentation. And you will find snippets that you just can use right away, because they are under the same license or under a similar license like Python is itself, because they provide it in a way that you start using Python, they are interested that you use Python, and so you just can use these snippets because they provide it as a sort of best practices, and you can start away using it. So try to find the official documentation of what you are using. For Python, it would be the Python documentation, and I don't know which version or which license is there, but at least there should be no problem to use it, of course, to write a code. But when you are somewhere else, I don't know, Stack Overflow, I have no idea what license is there for the code, then you most likely will get into problems. But yeah, I mean, it really depends, and the more you program, the less copy and paste snippets will you have in your code. So it's just
so that I know it by myself.
Yeah, you just start writing it down, and then that's it. And then you just copy those information that's coming from somewhere else. And also the problems become different. So when you have a problem, then you look up it somewhere else, and you just can take the concept or a specific hint how to access specific functionality of a library or something like that. Then the more you program on yourself, the more you are in it, the less you will start copy and paste, because you're just interested in one or two pieces of it, and you just take these one or two pieces which are then general enough so that you don't take care about any license issues, because it would have been able for you to write it on your own if you would have been available of the knowledge itself for yourself. So in the beginning, I don't know. I just can recommend, if you really copy large code blocks or functions maybe from other pages, clearly mark them that you have copied them, and also where the source from this is. And later on you will see if it matters or if it's not, if it not matters. Or you just sort out in the beginning that it's unproblematic to use it because it's a CC BY or something license.
One question. How do I know that it's published under license?
This is, I mean, if the information is available on a web page, you have to look at the web page. I mean, free and open source software community is big, and most likely it's there so that others are start using the code or the solutions they provide. And somewhere you will find a hint that it's no problem to use these information. But this is something that you have to find, and could be a bit time intensive from time to find. So this is why the recommendation is just copy the URL, and if you are really something doing where license matters, because when you write your code, license doesn't matter. It matters when you start publishing your code somewhere else. And then it starts to be a problem if, and this is also another thing, if your software might become big enough with a big community. So in the beginning, when you write a piece of software, it's small, and there's only you and maybe two others or something like that, no one will care about it. This is also a practical thing. I mean, if you have just an important thing for yourself and not for a huge community, then no one will care about it.
Okay. And if I copy it from the forum,
yeah, check out under which what are the conditions of the forum.
So the forum also can be under license.
Yeah, so they have, for example, when you're in a forum, you will have it's public, but those who are participating in the forum, they have mainly accounts to ask questions and to answer questions, and when they create the account, they have to confirm specific agreements, and within the agreements there is something that is saying everything that you put here is under public domain or whatever. Okay, the next thing is, because you are not doing it even, the next thing is when you're programming, it will be most likely connected to your work. That means you have to ask your institution if it's interested in any commercial exploitation of your software. Maybe it's such an important software that the institute itself can make money with your software that you have written. And so you have to ask your institutional service. For us at the GFZ, we have something which is called technology transfer. So you knock at the door, ask them, and they will most likely say it's a piece of software. It seems to be not to do very important stuff right now. We can't see any commercial exploitation here. Please go ahead. But from time to time, it can really be that they see a commercial exploitation, and then you're in a completely different activity. And then you have to ask yourself which license is the best for you and other stakeholders. That means if you want to make, it depends on what you want, because there are different sorts of licenses available, and you have to find out who is your community. Are you already part of a community? What license is used in that community quite often because it's accepted? Do you create a community? What sort of community is it? Do I give the code away and I don't expect anything? They can use it for commercial things. They don't need to make it open source when they make dramatic changes or something like that. Or am I interested in that no one is doing commercial exploitation based on my work, so I have to find a license which is covering that? Or am I also interested in changes in the code, so when someone else is taking the code, making changes, and is publishing the software, or using the software in a certain way, that you are still aware of these changes, is because the license forces them to publish their code as well when they make changes and provide their license. So, summarize it means the work of developers is complex at many levels, but in the beginning, when you start writing code, it's just important to know, okay, at a certain stage, maybe half a year, and 2 or 3 years, when the software grows and other people are interested in it, then you have to start to think about what license could this be, or even when you start using libraries or something like that, be aware what sort of license you are using, and then there are implications where you start thinking about over the next weeks and months, and then you will get used to it, and you finally, after a certain time, know automatically which license you will take, or you just have 2 or 3 licenses, and then the details are the important part to decide which license you want to take. Okay. Then, this is licensing issues. Is development of complex open source solutions is generally done by adapting and integrating multiple existing components, and the resulting application or solution may look as a single program from a user point of view, but is in fact a combined work. This is exactly what we said, that you are copying stuff, you are using libraries, you are using a specific language, and so on and so on. So these different components may be covered by different licenses, and the question is, are they compatible and legally interoperable? And this question only occurs when the aim is to redistribute the application to third parties. That means as long as it stays on your desktop, on your laptop, no worries, just do it. You don't have to care about licenses. But on the other hand, and this is what we have seen, is when you connect your workplace, your Git, to track your own changes, maybe to a GitHub repository, and you publish your code there, then this already is a redistribution of your application. So you are back in the licensing issue, and you have to ask yourself, oh, okay, I provide that stuff on GitHub to others. This is a distribution of the software, or redistribution of software. I have to think about licenses.
But if you open the repository as a private repository?
Then it's a private repository. Then GitHub is just your service provider. Even if you use, for example, repositories which are provided by your computing center, your computing department in the institute, then it's still private. Even if you have collaborators within the institute, for example, then it's still private. So if it's private, no worries. But if it's public for all, then you should start thinking about that. Okay, then there are 2 different license families. One is so-called permissive, and the other one is so-called copyleft. And permissive licenses like BSD, MIT, Apache, X11, and there are many more, are generally compatible and interoperable with most other licenses, tolerating to merge, combine, or improve the covered code and to redistribute it under many licenses, including non-free or proprietary licenses. So basically that means there are tons of permissive licenses out there, and if you use those permissive or libraries with those permissive licenses, it basically means go ahead, you can do with the stuff whatever you want, don't worry about it. And then there are also so-called copyleft licenses, which impose the use of the same license as soon the distributed work is a derivative of the covered work. Basically, we know these licenses. For example, this is the GPL license. There are two different GPL versions out there, which is GPL version 2 and GPL version 3. And another very unknown license, but very powerful license in the family of copyleft licenses is the EUPL, which is the European Union Public License, which is also very interesting and might be a bit better for our purposes than, for example, the GPL license. And basically, this means if you take a library which is GPL or which is under a copyleft license, it means you have to provide your code, which is based on GPL, again under GPL or the other copyleft license. And this can create, of course, license incompatibility when you use different copyleft licenses. And this may happen, for example, when you get a library which is under a GPL version 2 library, because this is one copyleft license, and when you have a GPL version and another library which is under GPL version 3. So version 2 and version 3 of GPL are not compatible with each other, and there's a conflict. And you can solve this conflict, or others can solve this conflict when they do something which is called dual licensing. So that means library or your software not necessarily has to be under one license. You can also say, hey, this piece of software is available under GPL version 2, it's available under GPL version 3, and it's also available under another license, for example. That means that others who are using this piece of software can, for their specific purposes, switch to this license which is required for a specific use case. However, when this is a huge piece of software where development continues with lots of people integrating their stuff and extending the software over time, then there are also over time specific problems which even I don't understand and don't want to understand, but basically it means the dual licensing is a way to resolve this problem, but it's not the best way because later on you will have other problems. And then there's also something, because there are also two ways of license compatibility. There's something which is called upstream compatibility and downstream compatibility. And that means upstream are the incoming components. So you merge the work covered by other licenses into a large work that you may distribute under a specific other license. And this is the scope of so-called license clauses for variable compatibility. We will talk about that later. And we have downstream compatibility, where the distribution of the result is considered. So when the work received under a license into a larger work that might be distributed under a compatible license, and this is also a scope of license appendixes. Now it starts to become complicated. But the thing is, the upstream way is that you have to check if specific licenses are problematic for yourself. So for example, in that case, this is a so-called compatibility matrix where you can see the over 60 OSI certified licenses. So there is an open source initiative, and these initiative files free and open source software licenses, because there are hundreds of licenses out there. And right now they have listed over 60 licenses which they say these are licenses which follow the free and open source software movement and underpin the ideas and the concepts. And they are listed on the left side. So what you can see here are these licenses. And the idea now is to say, this is, for example, a metric that is provided with a European Union public license. For example, I've written a piece of software. I want to publish my software under the European Union public license. Then I can look into this metrics, which I happily have, and can check library has this license, library has this license, library that has this license, and I can check if these libraries create problems with the license I intend to use for my software, the European Union public license. And many of them, or major parts of them, are in green, so there are no problems, but some of them, like GPL for example, which is the big red block in the middle, most likely when I want to use a European Union public license, then I'm in problems when I start using libraries which are GPL licensed. And then they are also different, and perhaps even more complicated. There are also different sort of how to use the libraries, because there's a sort of static linking, dynamic linking, and direct incorporation. So it means there are different sorts or different ways of how to use libraries. For example, incorporation means I just put it into my source code, or it's not part of my code, but I link to these libraries, and they have to be installed separately by those who are using my software. They have to also install the other software, and there are different sorts of linkings, which is static linking and also dynamic linking, and based on how I integrate these libraries in my code, it creates problems or not. This is something you should know, but possibly is something you really don't have to worry about, because in the beginning you will not work with not really work with static or dynamic linking from my point of view. Okay, when we look at the downstream, when we have a look at the European Union public license as an example, they have a specific clause which says, it's a compatibility clause, which is a very interesting clause in that case, because it says if the licensee distributes and or communicates, this is now this is a legal speak right now, so it sounds a bit different than we talk normally. If the licensee distributes and or communicates derivate works of copies thereof based upon both the original work and another work licensed under a compatible license, this distribution and or communication can be done under the terms of this compatible license, and for the sake of this clause, compatible license refers to the licenses listed in the appendix attached to this license. Should the licensee obligations under the compatible license conflict with his/her obligations under this license, the obligations of the compatible license shall prevail. So you don't understand anything. But it means, and this is the nice thing about the European Union public license, it means work that is distributed under the European Union public license normally has to be redistributed under the European Union public license again. So someone else is using your software under the EUPL and is doing something with it, then he or she has to distribute it under the same license. Except, and this is the nice thing about the EUPL, when the other person is using a GPL licensed library, then the European Union public license says, okay, GPL is something that we support as well. We understand that they have also their specific license rules, and then it's fine when you continue with the GPL. No worries, you don't need to continue with the European public license. The whole work then is published under the GNU GPL, which is a compatibility which is not available in other licenses in this way, which is very nice. Then you have a sort of exception list. I don't like to go into that, but basically one example is, for example, MySQL has a so-called FOSS exception list, and normally it's distributed under GPL version 2, and with this exception list they allow that derivates under other licenses then can be also distributed under these specific licenses, which basically means you should have a look at bigger projects, what sort of license is it, and if it's a copyleft license, do they provide a sort of exception list, and if this exception list also contains the license I'm using, then everything's fine. Then another very interesting case is something which is called license provision, which basically allows you to extend a license in a certain way. That means you decide yourself, you decide that your software goes under a specific license, like the European Union public license, but a specific case, for example, is not covered by that license. In our case, for example, we have questions regarding software licenses in general when scientific results, such as figures or numbers, produced by the software are used to publish findings in papers or scientific journals, which basically means someone else is writing a paper, or someone else is writing a paper, is creating data or is creating figures, and is presenting the work in papers, but is not distributing the software. But the software still is under European public license, and in this license nothing is written that he has to open the software in a way. So that means there's a paper out there which I can't reproduce, and I even can ask the author, please show me your software, and the author can say, no, I'm not doing that. And you can use this license provision. For example, it would be beneficial if a software license would cover this case, so that the source code has to be provided for any modified version of the software that is not distributed. It's still on the desktop of the researcher who just has published a paper, but that is used to produce results which are presented in scientific paper, and there's almost no license out there which is covering the case, and in this way you can, for example, start using these additional provisions. And what you can see here is that this is a header of a source code file, which has been, so under this header you will have a lot of source code, and this is the main program, but in front of it, it says that this is a specific piece of software named this and that, it's doing this and this, and it's copyrighted by this institute and these two authors. So this is the copyright information. Then you will have also the project information, because when you are developing software in a project, you, like in a paper, you have to say that this work has been done in the project XYZ under agreement and funding by the European Commission of blah blah blah. So you have to integrate this project information. And then there's the information. The first two lines are white, which means licensed under the European Union public license, blah 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 blah. And then there's the next part of the license, and in between that it says that this European public license is complemented with the following provision: for the scientific transparency and verification of results obtained and communicated to the public after using a modified version of the work, you, as the blah blah recipient and so on, commit to make this modified source code available in a repository that is easily and freely accessible for a duration of 5 years after the communication of the obtained results. And basically this is an additional provision which says, if you take my code and you make changes to the code and you write a paper about it, but you don't publish your software, you have to publish your software, because we want to reproduce your paper. This is the main sentence of this additional provision, and it extends the library to a specific use case that you feel that possibly is not covered by the license alone. So with these additional provisions, you have sort of way to make modifications and extend things in a way that others have to do a bit more than normally with a license. Okay, then let's have a final look at the license requirements of the European Commissions. They identified their own challenges, and they of course had a broader look which is covering Euro. And the first thing is that they want to grant all free or open source software freedoms. They want to ensure protection from exclusive software appropriation. they have a working value in all official European Union languages, which is very important. That means there's no need translation in court or related institutions for translations. So this, for example, is a big deal, or has been a big deal when some certain things under GPL here in Germany happen. Then you need a specific translation which is relevant to the specific court, and this is just covered by the European Union public license. And each translation also is using the European copyright law and a specific terminology. So the terminology used in the German translation of the European public license is a bit different than in the Polish license translation, but it's still using a terminology which is relevant and legally correct in the specific country, which is very important. Another important thing is that they include the communication to the public right, which basically means that you can also provide software as a service. I don't know if are you familiar with this concept? We have been talking about redistributing software, which basically means you bundle a specific package and let others install the software and they can start using it. This is a redistribution. But with the new concepts and with the new technologies, you can even start install the software on a specific computer or server, and only the service is provided to others. And now the question is if this providing this service is a redistribution or not, and to cover this, it basically means communication to the public, so that the software as a service principle is also covered. That means even if the software is not redistributed to others, but only services based on this software are provided to others, then they still have to open the source code. And then there are some other relevant for the European Commission relevant requirements which have been met with the European public license. It's summarized again here, which is the uniqueness in the European public license. Personally, I didn't know something about the European public license last year. It was something that I was just discovering this year. And the more I get introduced to that stuff, because I'm not doing it from one day to the other, it took a long time to understand a bit of this license, and I'm still exploring new things in this license. But when it comes up to if I should decide for using GPL or European Union public license, I most likely would use the European public license. Just to let you know that if you want to stick with the copyleft license, you shouldn't just fall back by default to the GPL, just have a look at the EUPL. And summarized, that means use a strong license. It could be the European Union public license if it's a copyleft license, but it can be also a very strong license if you use a permissive license like the BSD or something like that. It really depends on, because license is a tool. You decide what sort of license is used dependent on your goals. So it's part of a strategy, what you want to do with your software. Would you allow commercial exploitation? Is it fine when others just take your code and do whatever they want to do with it without opening it anymore, and so on and so on. Check the compatibility for distribution and resolve the conflicts. We have talked about that in the beginning. And try to consider licensed provisions just in cases where you want to cover specific cases that are not really covered by the license itself. For example, if you want to have reproducible papers, you just can copy and paste the example we have provided in this presentation. So, any questions? Okay. If not, then there is one final thing that I want you to do, because we want to have an evaluation. I just see it. We can also open that quickly. We will have on November the 18th, we will have here in the conference building, there will be the GIS day. I think call for contributions is still open, so when you are doing some sort of GIS magic or you write code or something like that, you are invited to present your work there, or you just register to get 1 day of GIS software, what others are doing, and you are invited to join this day. You just need to register, and then it's in the middle of November, and it will be much fun when others present their work. And it would be also nice if maybe if you are working with GIS tools or extending them or whatever, you can even present them in very small presentations or with a poster or something like that. Just a side note. And then I would like to thank the speakers. Where only one is here left over. Thanks to Marta for coming. Also, thanks to Peter and Hussein. I think all of them made a great job. But for me, it was at least for me, it was a very good workshop. I learned a lot of stuff. And finally, we want to know if the workshop is something that satisfied you, if you have been happy with it, and it now depends if you would like to do an evaluation form right now on these computers, or if I just should write you an email and you do it the next week. It's up to you. I can provide the link directly or right now, and it's done. Okay. Check. Find the link.